Yeah, Panton. We'll talk about WebRTC and why you might care about it. So, I guess the first thing to do is find out whether anybody's not used WebRTC. Hands up, people who haven't used WebRTC. Excellent, good. An audience who needs maybe a little info on this. So, next question: who's got a laptop that's on the Wi-Fi here? Okay, and with Chrome or Firefox on it? Excellent. So, browse to that URL, and we'll do a little high-risk experiment.
No tiny URL?
You should make a tiny URL.
Yeah, I should, but I haven't. So, whenever anyone's...
I can't see the URL.
Oh, okay. Yeah. So, it is tediously long, so maybe stand up and read it for yourself, actually, it's probably easier.
When you connect it, it should say some snippets of the restricted demo for them.
Yep, sounds good. So, you're now waiting for a call from me, which may or may not work. Assuming I'm on the Wi-Fi, which I'm not. Connecting. Yes, that's always the Wi-Fi. No, still don't have Wi-Fi. We'll do that in a minute. When my Wi-Fi shows up on here, I should do that. So just hang around on that page and something will happen in a second, hopefully. So what we would have just done there, had it been working, and we will do in a second when my phone decides that it wants to join the connected universe, was to place a call between two web browsers on two different platforms. Potentially two different web browsers, depending on whether the recipient ends up on Chrome or Firefox. With no plugins, no previous setup, and pretty much nothing to rendezvous except a single URL, which is actually kind of cool. And we did that with no config, just by browsing to a site. And the call would have been encrypted free, but in kind of almost every sense. And interestingly, and this is kind of unique to WebRTC, over the local Wi-Fi. So the two peers, it's a peer-to-peer call, and the two peers find each other, and they find the most efficient route between each other. And if they can route that over the local Wi-Fi, they will do that. So if you've got a low bandwidth DSL, but you've got high bandwidth within your office or within your home or within your campsite or whatever, you can do a video call across that traffic. And that's kind of, like I say, I think that's new. And the combination of those things I think is especially interesting. So, a little bit of stepping back into definitions. So WebRTC is real-time voice, video and data, browser-based, no plugins, secure and interoperable. So those are the kind of goals for the WebRTC project. And to date, I think they've probably met them. And it's based around standards. It's a standards-based project. It's an emerging standard from both the IETF and W3C, which again is kind of unusual. But these two standards bodies took the view that there were wire protocol issues that needed to be addressed, and that's the IETF's job. But there were also API issues and browser issues about what this API should look like in the browser, and those are the W3C's domain. So the two standards organizations cooperate and have produced, are in the process of producing a standard. And in that process, various companies have contributed literally hundreds of millions of dollars worth of IPR in terms of codecs and core code to make this stuff work. And they've donated those to the project, and they're all open source under various licenses, but none of them too restrictive. And those companies are people like Google and Cisco and Mozilla and Skype, and the company I work for, Tropo, and AT&T and Ericsson and Lucent, like all of the big names have put effort and resource in, with the exception of Microsoft. Although that's unfair, because Microsoft via Skype have donated a codec, so that's an unfair criticism. They're interested, they're standing slightly back from the process, but they are involved in it. And Apple are, as is traditional with Apple at this phase in the standards process, saying absolutely nothing. Whether Apple will go for it or not is unreadable. My guess is probably they will, but you can't be sure. So, to misquote Mark Zuckerberg in the social network, you know what's cool? 1 billion endpoints. That's what's cool. So there are, at this point, and you can look at the statistics and whether this turns out to be true this week or next month, there are roughly 1 billion endpoints that already speak this protocol. There are 1 billion devices with browsers sitting on them that already speak this protocol. That's huge. I mean, that's like, I don't know, but it's bigger than any telco. Bigger than any single telco already, and we've not even written the standard yet. So, little bit of kind of big picture story. We made the decision in the standards body that we didn't want to standardize this piece. We took the view that it was not our business in the IETF or the W3C to agree how the two endpoints would find each other. That is a domain of your web service, your social network, your email, your carrier pigeon, whatever. There are a couple of blobs of data you need to exchange between the two so they can find each other, and from then on it's your problem. To achieve that is your problem. And that means that we're making no assertions about identity. You can manage the identity, you know, I'm Tim, you're Bob, whatever. You can use whatever namespaces you want. That's an attribute of your website typically. You may have logged in on the portal page as Bob53 on, you know, Bob's social network. And that is as a web developer, that's your responsibility to manage. We have, as the standards body, we've stayed well out of that. The only piece that we actually manage is the API you use here, and that's the W3C's domain, and what goes over the wire between the two endpoints once that call's been set up. And that's the IETF's domain. So, just looking to see if I'm in this right way yet. I'm still not. I'm one more shot at it.
The business one works.
Sorry?
The only one, the business one should work. The business, if the password one.
I'm sorry, so
The other one that says business, it works like now.
Wuthering Bytes.
oh, okay. Let's see whether I can get on something. Avoid internet connection. Well, let's try and connect.
Are you on the one called the Town Hall?
I'm just about to try that one. I've got
Yeah,
a good
it's on-
workshop. So they turned off the. Oh, we're connected. So I'm now on Town Hall.
Yeah.
So hopefully somebody else is on Town Hall and was on that page that we.
Business.
Own business.
Yeah, the business one.
Oh,
It
okay.
needs Wi-Fi password.
It's up there on the wall, it's on the wall.
Oh, that
By the window.
Can you put the URL up again?
Yes, that would make things a lot easier. So, back to that. Let's try that. Now, I will do that at the end. It's more traditional to do demos at the end anyway. So, where were we? Yeah. So, this is the code that the person making the call has to run. Now, it's slightly simplified because we're using a library that I've been involved in writing for Phono, which wraps up some of the WebRTC stuff. But basically, all we're doing is saying where our video containers are on the web page. Then starting Phono, initializing it with some parameters, telling it whether we want audio and video or not, and then what to do once it's ready. And what to do once it's ready is go and find from a web service the ID and some other data about the person on the other end, and then go and dial them, and that's it. That's a full video call in whatever that is, 15 lines. And that, as I say, will work on Chrome and Firefox, and it will work on Chrome on Android, and in the future it will work on other platforms. So that's a measure of how little code you have to write to get this stuff working. So I'm working on Phono. This is why I know about this stuff. What we're trying to do is to produce a clean, high-level API, as you saw, to allow people to use WebRTC. And we're doing this jQuery plugin so that jQuery programmers, in general web programmers, feel comfortable with it. We mask some of the complexities of WebRTC, and we also offer for IE and Safari a fallback to Flash, so that if you really can't get things work, you can't find a browser with WebRTC in it, then you can fall back to Flash, and at least the audio call will work. We don't have video working over there yet. We also run a gateway to SIP and PSTN and traditional telephony, because that's kind of where our business model is. And then there's phono.com, which is a website which hosts this and has demos on it, which you're welcome to browse to. I might at some point. And then I think, when this follows on to the previous talk, very relevant is the data channel. We've been talking about video and calls and stuff, but actually the data channel is a whole other layer, which provides the ability to exchange peer-to-peer data between two browsers without going through the web server. Now that's fast, and it does that. It's not a long holding or anything. It's actually sending packets. So having set up, the trick is having set up a connection that's of a quality that you could run video and audio over. The view is, well, hey, why don't we just put another packetization over that and run data over it as well? So that data channel is then exposed to the JavaScript, so you can throw game controls, data from your thermostat, whatever it is, over this channel. And my view is that this actually might turn into a bigger thing than the audio channel or the video channel, because the ability to keep an eye on the state of various Internet of Things devices in your browser in real time without polling via a web server could be a big issue, could be very interesting. And my gut feeling is it might be like if you're old enough, maybe SNMP. So there's a low-level protocol that carries a lot of raw data around the internet for management of the internet, but that actually nobody sees. I suspect this protocol may do that, but bubble it up into the web browser. I could be completely wrong. This is that's probably the most speculative thing I'm going to say, but my instinct is that it's there. This is it's a beautiful demonstration of this. If you want to exchange files between a couple of people on a Wi-Fi, like here, sharefest.me does a fantastically good job of it. If you browse to sharefest.me and one of you drags and drops a file onto it, then you get a short URL. I should demo this. Take another high risk. Where is my dog? Where is he? It's on that. Yeah, there we go. So, very weird typing on his shoulder. So I can drag and drop the file to there, and then let's do that. It's fine in the presentation. I can take this file, drag it onto there, and then anyone who chooses to go to that URL now will download. If somebody could, that would be brilliant in Chrome. So that's 7136. 63.
I'm connected to one here and it's going to take me infinity years to download.
Yeah, and hopefully, if you're on the same Wi-Fi, it'll. There we go, connected to no pins. That's interesting. Are you on the same Wi-Fi or different? I guess different. Okay, there we go. So that's presumably, from the speed of it, it looks like it's routing out through the internet back through another Wi-Fi. But it kind of doesn't matter. It just proves that it works. And this is entirely. Oh, somebody's got one. So I think that's. And that's all within the browser. It's like neither of us installed any software other than Chrome. And the lovely thing about that URL is it's ephemeral. Once I close that browser, I've stopped sharing that file. So if I leave it open for the next 10 minutes and then close it, that's the window of opportunity. This is the other. This is brilliantly silly. It's another demo I love. This is completely pointless. I want you to understand there is no point to this whatsoever, other than it can be done. Should have lyrical displays, I really should. Okay, so you can now see me bouncing out. Now, what that proves is that the video codec is exposed to, this is all written in JavaScript, mind you. So the video codec exposes itself to JavaScript, and then some clown has written something that looks at each of the individual pixels and ASCII arts them in JavaScript. Now, I can say that has no real use, but the fact that you can do it is fantastically cool.
It's art doesn't need use.
Yeah.
I mean, I suppose you could use it for one of those documentaries where the actors, these things are spoken by an actor. You don't want to see my real face. I think that indicates the sheer malleability of the data, that you can get at it, that you can do stuff with it. And I think that's in itself really exciting. I won't do this demo, partly because I'm running low on time. But what this does is it plugs in an audio and conference into your Jira page. So if you're running an agile development group, then you can assign a Jira page and say, whenever any of my group goes to it, then there's an audio chat that they can be dropped into with a single drop down from Chrome. It's a Chrome extension, so you kind of have to install something, but it's really minimal. And that just means that the team can chat amongst themselves. So I've kind of cheated so far because I've said that this is going to change the world, but I haven't told you how yet. So I'm going to tell you now. I think my experience, and I suspect probably all of you, the landline is a nuisance. Like the call is going away. Like the call as a concept is just a pain in the neck. Like, I don't want to be rung up. I don't want to be disturbed when I'm in the middle of something. I want to be much more able to manage my interaction with the person on the other end. And the call with traditional telephony really doesn't support that. So I think what we're interested in is things like goal-directed behaviours. Websites are really good at doing that. There's a car insurance site and it's for getting car insurance, and you go through the process of getting car insurance. And that sort of behaviour, I think, we want to see more in telephony. And you want to apply web metrics to it. You want to use asynchronous behaviours rather than synchronous ones, so I don't get disturbed when I don't want to be. And the web is perfect for innovation because it lets you do A/B testing, it lets you get at 1 billion people in principle. And the flip side of the web is that it's way too silent. There's just not enough of the human voice in there. The human voice is still our best communication medium. It's our best way of conveying new ideas, of demystifying, of deconfusing people, of convincing people, of conveying emotion. It's simply the best way we have to do those things. And the web just doesn't support that in any sensible way. And I think WebRTC gives us the opportunity to do some of that. So WebRTC has the following attributes. It's peer-to-peer, it's secure, and it's secure with reasonably recent crypto, things like elliptic curves and pivot-forward secrecy. It's open source and it's decentralized. That means that it is potentially somewhat eavesdropper-proof. Now that is kind of a contemporary, interesting thing. But let's say for the moment that you're a charity worker, an aid worker, a lawyer, somebody with a legitimate expectation and requirement for privacy in your communications. So I'm not going to do the politics here, just those people, there are situations where they could expect and should expect a degree of privacy. What's interesting about WebRTC is that although it's not secure against a targeted attack, if somebody actually installs a virus on your computer or installs a keylogger on your keyboard or fakes up an audio device or something like that, then or rewrites the BIOS, it's not immune against that. Those sorts of things, the browser is too high up in the chain to help. But it is immune potentially to signaling attacks, in the sense that setting up a call between A and B is kind of being, we've seen that it's being mass monitored at the moment. Now, WebRTC is somewhat immune to that because basically anyone can set up a WebRTC site. So in theory, you could have like every single WordPress site is a WebRTC site. And they might use different code, or they could run it on Pi. So instead of being in the business of attacking one global PSTN system and Skype, if you're wanting to attack that kind of thing, you have to attack every single one of all of the possible sites that might be running WebRTC, and that's a big target space, and it's expensive. So that makes signaling attacks much more difficult than they are at the moment. And so the next layer up would be, well, okay, so we'll attack the browser. Well, the browsers are somewhat immune to this because the browsers that support WebRTC at the moment are both open source. So the code is inspectable. And if you're really worried about it, you can build it yourself, or you can get a third party to build that for you. There are sites who build trusted Chrome that inspect the code and only release it once they've done an inspection on all the changes. And they build it in a clean environment. And those are actually extensively used by charities already. So, to some extent, we're immune to that level of attack in the way that things like Skype simply aren't. And the media, over the wire at least, is somewhat immune to being attacked as well, or being recorded, because the media is encrypted from peer-to-peer. There are multiple implementations of that encryption, and they're all open source, so there's a good chance that somebody would have spotted a hole in that if there was a hole. The keys are ephemeral, so the keys don't persist from session to session. So you have to attack this session, so it means you have to be actively attacking that particular session rather than speculatively picking up all the traffic there is. I mean, you can pick it up, but because of the way the keys are generated with DTLS, pretty much immune to retrospective attacks. So having captured everyone's data for the last 6 months doesn't help me because I don't have the keys to decrypt it, unless I do a brute force attack on them, and that's expensive. The keys aren't in the logs. The keys never travel over that signaling path. They're exclusively between the endpoints. And I think this is actually probably also huge in that if there are 1 billion people using this, there's a lot of chaff to sort through to find the thing you're interested in if you're trying to attack. So to some extent, just the sheer volume of people using this makes it much more difficult to intercept the 1 or 2 things you're trying to get hold of. Unfortunately, it is vulnerable at the moment to man-in-the-middle attacks. There's no validation, there's no easy validation that there isn't somebody sitting in the middle decrypting the call and re-encrypting it. The data is there to detect that, but the only way that you can do it is one of you sits there and reads out a 256 byte hash key, and the other one says, yeah, okay, I got that, which isn't practical. If you look at something like Silent Circle, they've got that down to, I think, 4 short words or something, which is a much more practical thing. So, but in my view, that's a user interface problem. That's a matter of trying to represent that chunk of data in a way that 2 users can exchange and over voice or over video or in some way compare and contrast whether those things match up or not. And I hope that somebody, maybe in this room, will sit down and think about that problem as a user interface problem and solve it. It's not my skill set, but I think it would be really interesting because there's a lot to play for in this space. If we can get this right, we can produce a decently secure communication channel for a lot of people who need it. So, I want to conclude with a little observation, which is that in 1905, physics looked like it was completely done and dusted. Physicists pretty much knew how the universe worked. We understood Newtonian physics, and it modeled everything we were interested in, barring a couple of minor things that we didn't really care about. And then those edge problems, one of them was the photoelectric effect, which just wasn't amenable to Newtonian physics at all. And investigating that revealed the entire quantum universe. And my view is that communications has got to that sort of point. You know, we think we understand exactly what a call is. That's just how phone calls are done. They've always been done like that. We've been doing this for 100 years like that, and that's just the only way you can do it. Video calls and mobile phones are just a minor extension of that. My view is that if we dig into WebRTC, if we dig into the possibilities of WebRTC, and pull in some of the ways that the web thinks about approaching user experience problems, then we can open up a communications universe, particularly for voice, but also for video and data. And I think that that's a really, really exciting opportunity, and I'm loving being involved in it, and I encourage you all to dip your toe in it and see whether it's something that you can play with, because I think it's a huge opportunity. So that's all I've really got to say. I'm Panton, Steely Grant on Twitter, dropper.com, and love to take some questions.
I've got a quick question, if that's all right. Do you have control over things like frame rates, resolutions, and
at this instant, no. There's discussion in the standards groups about how that should be done, and there's a battle going on, and I'm firmly in one camp, so I'm going to try and be neutral, and it's just going to be a strain. There's a camp that says we need to control this at the level of, this codec using this number of bits at this frame rate, precise numbers, and that means that you have to understand how the codec behaves, and you have to know all this stuff. And there's another camp which says, actually what we want to do is get the web developer to express their desires. They want, they're more interested in frame rate over picture quality because it's a fast moving scene, or maybe they're more interested in picture quality than frame rate because it's another, it's a gardening program. So you might want your content to express what your preferences are, but not dig down into I want PPA in this mode with these 7 parameters. And that battle's going on. I'm hoping that it'll get resolved. It will get resolved one way or another. I'm hoping that, of course, that what I want to happen wins, but whatever. But so yes, there will be, but no, there isn't yet, because that standard hasn't been written. I think Chrome exposes things like, Chrome exposes the resolution, but not frame rate at the moment.
It's called WebRTC, but am I right to understand that basically it's a protocol and it's implemented, like there are libraries to use it for native apps or mobile devices and things like that too?
So formally, WebRTC is the JavaScript API. So in a sense, if you're going to be strictly kind of standards compliant, WebRTC can only run in a browser or a browser-like thing. The low-level media protocol technically is RTC Web because that's what the IETF called it. But that, yes, there are libraries for that you can build into native apps on an iPhone or whatever. And indeed onto things like the Pi, which I think is probably more interesting. And so yes, you can do that kind of interoperability, but formally it's not called WebRTC. But I'm being pedantic there.
So one of the questions that I had was about machine learning and the fact that in Canvas now, if we drop a video stream into it, we can actually do machine learning, like using high cascades and stuff. Have we seen any WebRTC video chat stuff do like facial recognition so that we can apply names to people on screen?
I haven't seen one doing actual recognition, although there is a library that in theory would do it. I've seen Chrome have a demo which puts a parrot hat on your head and follows you around as you move. So facial tracking rather than recognition. But there's nothing. I think the only thing that would slow you down is that you've got to write this stuff in JavaScript, or you've got to write it. In Chrome, you could do it with NACL and write it in C, but that's a whole other game. So I suspect that recognition might end up being a step further along the line. And I should add that the same is true for audio. The audio channel is also exposed to what is the most beautiful API I've seen for ages. The web audio API is just gorgeous. Anyone who's like a tinkerer with synthesizers should go off and look at the web audio API because it's glorious. 5 lines of JavaScript and you have a little synthesizer or a low-pass filter or an echo chamber or whatever. It's just, it took them 2 or 3 revisions to get it right, but it's glorious.
Yeah, there are some examples of that. People have been doing web-based patch synthesizers.
Yeah.
Fantastic.
Well, now you can feed in somebody from the far end of the communication channel into that as well, which whether that's useful or not, I don't know, but I just think it's great.
Does WebRTC have fallback for the poll? Because you say currently you just work with Firefox and Chrome. I've just started in researching Signal R, the Microsoft version of it, and that falls back on the different kinds of polling, so it's real time if the browsers are Chrome and Chrome, but if it's Internet Explorer, it'll fall back to long polling.
Yeah, so that's what Phono does as well. Phono does long polling. So the API, the data channel API, looks very like WebSockets. So what you could do is just detect in your browser, do we have a pair? No. Okay, so we'll use long polling via a server.
Yeah.
Or we'll use WebSockets. But the downside of that is you're always going out via a triangular path through a web server, and the web server's probably got other things to do.
Because I'm currently using it to build a booking system, a real-time booking system.
Right.
And I'm finding it really interesting, actually.
Cool. No, that's great. And
Yeah, is it purely peer-to-peer? So is it a single peer to a single peer, or could you use it for conferencing? And if you do use it for conferencing, the more people that connect to that stream, the more your bandwidth is going to be limited, so therefore you're going to have to slowly reduce quality. And that comes back to the whole limitation of frame rate and encoding.
Yeah.
More people which are there, the more squeeze you've got.
So there's a series of really interesting problems there which a lot of us are thinking about. To what extent? I mean, my gut instinct is that 4 or 5 you could mesh, so you could do them in a peer-to-peer with a mesh, and you just have to manage the frame rate, as you say. At some point that just fails, and you end up having to have a star algorithm. And then whether you mix in the middle or you switch in the middle, depends a bit on what user experience you want, but you end up having to have a chunky server in the middle that's doing something, maybe just reflecting the packets. But there's a possibility that you could do something like, I don't know if you remember the Cambridge ring, but you could, instead of having a mesh, you could have a ring and use the data channel to pass things around the ring. I haven't really worked out whether that would work or not, but it feels like maybe there's something you could do there. So that maybe that But I love the fact that this is a place where people can, with a web browser, start looking at network topology problems. It's kind of totally unexpected but cute.
Is that why it's only been sort of tested on like 4 endpoints at the moment? There's samples of it being used for endpoints.
I think I've seen, most of the people who are doing this see themselves as commercial services running the conferencing engines. So there's a big disincentive for people to write more than 2 or 3 because they want people investing serious energy into it are interested in running that in the centre. I'm guilty of that too. So because I think it's an interesting space. Anything else?
Just have one more question about security. When you negotiate a layer and you've got a WebRTC tunnel between 2 clients, am I right in saying there's no prompt until you want to access a piece of hardware on that client's machine? So you can actually create a tunnel between 2 end users without them knowing about it, is that correct? Like I can visit your website, you can create an RTC tunnel between me, and if another user visits your website, you can then tell
us so you saw that with ShareFest.
Create a tunnel, right?
You saw that with ShareFest. There was no permission asked for with ShareFest.me.
Right, yeah. So my question on that is, say I've got a tunnel between myself and some of the guys back here, but I don't want anybody to know that I've got a tunnel between these guys. Is there any way that anybody can see that we've got a connection between us? For example, an ISP, will they be able to know that we've got a connection between us?
Yes.
And then my subsequent question from that would be, isn't that a great way of, if you did want to hide yourself, to literally mask yourself in and amongst a lot of different connections and people?
So
to obfuscate, essentially.
I think the more people do this, the more obfuscated the space will be. Yes, your ISP, inevitably your ISP can see what outbound connections, what outbound packets you're sending, what inbound packets you're receiving, and there is frankly nothing you can do about that. The only thing you can do is hide in volume, I think, and obscure the content. Anybody else? No? Good. So I will, at some point, anybody who wants to do a video call with me, come up to me, get us on the same Wi-Fi, and we will actually do it.